Hello students, welcome to Aditya Academy. I'm Dr. Ragini Arora and today we are going to start chapter 9 from NCERT, and this chapter is about the applications of trigonometry. I hope you must have seen the videos of chapter 8 in which we had learned about the trigonometric ratios and how to use those ratios for practical purposes that we will learn in this chapter. Before starting to use them in the questions, first of all we should know two new terms. One is angle of elevation. Angle of elevation. Now, how does this work in practical applications? You must have seen that if we are standing on the ground, right? If we are standing on the ground and we are watching and looking at something above in the sky, like somebody is flying a kite, or we are looking at some aeroplane which is moving in the sky. So when we are standing on the ground and an object is there in the sky or at some height, it may be in the sky or at some height. It may be just like the second floor of some building or first floor of some building. So that means the observer is here. Observer is here. And the object which has to be seen is at some height. In that case, say this line is called the height. The vertical distance of the object from the point just below that object on the ground is called height of that object or altitude, right? So when we are watching something at some angle, we are looking at something at some angle, then our eye is making an angle with the ground. That angle is called angle of elevation, because we have to raise our eyes to look at some object which is at some height. In that case, the angle which our eye is making with the ground at that particular moment is that angle of elevation. In that case, the observer is at ground and the object is at height, right? So the angle of elevation is here. Now you must see that this is the case of a right triangle, and we had learned in the last video that we have two acute angles in this case. So right now we are talking about the angle between the base and this line is called line of sight. Line of sight means when we are looking at some height, that means the object is at some height and we have to look at that object. Then we have to raise our eyes. And the angle that our eyes make with the horizontal line at the ground is called angle of elevation. This is called line of sight. The object is here and observer is at ground. So this is the diagram. You can see that line of sight. This is line of sight. The person is looking from here to some object at C. Here we have our object and the observer is here. Observer is here. And the vertical line, perpendicular line which joins the object to the point which is exact below that object. This is called height. Vertical height. Now the angle of elevation is the line of sight is a line drawn from the eye of an observer to the point in the object viewed by the observer. So this is our line of sight, which is the direct link between the eye and the object. Eye of the observer and the object. The angle of elevation of the point viewed is the angle formed by the line of sight. This line of sight and with the horizontal when the point being viewed is above the horizontal level. So the object is at some height. This is the height. This is the height and we are looking at that object from the ground, horizontal level. In that case, the case when we raise our head to look at that object. So this angle in this right triangle is called angle of elevation. And we will be just using this concept to take trigonometric ratios and find different things when we are supposed to do that in a particular question. Next term is angle of depression. So this is the case when we, like in the previous case, the object was at some height and the observer was standing on the ground at the horizontal. Now this is the opposite case. The observer is standing here at some height. Observer is standing at some height, and this is the vertical distance of the observer. The observer is standing at a height h. So this line represents height. And now he or she is looking at an object which is at the ground. The object is here, right? The object is here. So the person standing at the height is looking at an object which is on the ground. Now the person has to drop his or her eyes. See, this is the line which is parallel to the horizontal. Now the person standing here has to look down, or has to look down through the horizontal line and to see that object. Right? The observer has to look down or lower down his eyes to look at the object which is lying at the ground. That means the eyes of the observer is making this angle with the line which is parallel to the horizontal. So this angle is called angle of depression. See, you have to feel that when, like, I'm looking at this camera, so this is the level of our eye. If I have to look at some height, I have to raise my eyes. So that in that case, the raise between the horizontal and the line of sight is angle of elevation. And when I have to look at an object, I have to lower down my eyes to see something which is below the level of sight. In that case, it is formed angle of depression. Right? See, in this figure, this is the horizontal level, because the person standing here, this is the normal sight. Person, when looking at the normal level or the level of the eyes, not below or above, that is the horizontal level. And if the person has to look down to see some object which is at some lower level, this angle between the horizontal level and the line of sight is called angle of depression in this case. Right? Thus, the angle of depression of a point on the object being viewed is the angle formed by the line of sight. This is line of sight. This is line of sight. Line of sight with the horizontal when the point is below the horizontal level. The object which is to be seen is here at the horizontal or the ground, which is below the person who is looking here in front of her. Right? This is the normal viewing level. Now, if she has to look down, she has to lower down her eyes. Now, the eyes will be making an angle with the horizontal level for her. So, this depression is called angle of depression. Right? So, these are the two very important terms. You simply have to remember the object is at ground, observer is at top. That means you have to make angle of depression. And if the person is, like in the previous case, if the person is at ground and he is looking at an object which is at height, that means he has to raise his eyes. In that case, we have angle of elevation. So this is all that we have to learn. Now we can do some questions to use these things practically. This example says a tower stands vertically on the ground. Now this applications of trigonometry chapter is very interesting and very easy. The thing is, you should be able to make figure properly. And if you have grasped these two terms, I don't think there will be any difficulty learning this chapter. A tower stands vertically on the ground, right? From a point on the ground, which is 15 meters away from the foot of the tower, 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is found to be, see, this is the tower, right? Tower is here. It's a vertical object, so let this be the height of the tower. Now from a point which is 15 meters away from the foot of the tower, let this be point P. From this, the angle of elevation of the top of the tower, let this be. Angle of elevation means if we are standing at point P and from here I am looking at the top of the tower, that means I am making an angle of 60° with the horizontal. The angle of elevation is found to be 60°, and we have to find the height of the tower, right? So this is the simplest question. In this, you have to simply find the height of the tower, and the given things are the angle of elevation and the distance of this point from the foot of the tower. So initially we have to write, we have to label this, let QR be the height of the tower, right? Let P be a point at a distance of 15 meters, right? 15 meters from R. Now angle QPR is equal to angle of elevation. Angle of elevation here is, and this is equal to 60 degrees. You have to label these things initially in the introduction part, and then you start doing. You have to mention the name of the triangle. In right triangle QRP. Now what we have to learn here is, we have to solve this question. We have to find the height of the tower by using some trigonometric ratios. What you have to do is, now you have to analyze what ratio works with this angle and this known or given thing and unknown thing. See, angle is given to us, this horizontal distance is given to us, we have to find the height of the tower. Now, as we had learned in the last chapter, that the angle which is concerned angle is formed between the hypotenuse and the base. This is 90 degree, this side is hypotenuse. Now, according to that, this RP side becomes the base, and this has to be perpendicular accordingly. Now, these things are fixed. You have to search for the ratio which works between the known and the unknown part of this triangle. That means known part is this RP, which is base, right? One is base, and the other thing is perpendicular. We have to find perpendicular. So which ratio is related to both of these things, perpendicular and base? So this is either cos, perpendicular and base. This is tan, sorry. Perpendicular and base. So either tan works for this or cot works for this. So tan is basically the relationship between perpendicular and base. So here we can take the tangent of this angle. In triangle QRP, tangent of 60 is the relationship between perpendicular and base. Here the perpendicular is QR and base is RP, right? Tan 60 value is √3, and QR we have taken as H. You can write here, let height of tower be, let height of tower, okay, we had QR with the height of tower, you can write here as H, right? So all these things you have to mention in the introduction part. And then this is H, this is unknown part, and the known thing is the base is given to us. So from this relationship we can do cross multiplication and we can find H is equal to 15 √3. 15 multiplied by √3, and this is in meters. As this distance is in meters, so this height will be in meters. And if this is the question, unless it is given that you have to take the value of √3 as 1.732, you can leave this answer in this format with the root. H is equal to, provided root is not in the denominator. This is our height. Then you can finally write height of tower is equal to 15 √3 meters. Do not forget to write the units, right? So this is the basic question. The next question is, an electrician has to repair an electric fault on a pole of height 5 meters. She needs to reach a point 1.3 meter below the top of the pole to undertake the repair work. what should be the length of the ladder that she should use, which, when inclined at an angle of 60 degree to the horizontal, would enable her to reach the required position. Also, how far from the foot of the pole should she place the foot of the ladder? See, in this question, electrician has to repair an electric fault on a pole of height 5 meters. Right. So, see, this is the height of the pole. Height of the pole is 5 meters. Right. But she needs to reach a point 1.3 meter below the top of the pole. That means she has to reach here. She is not required to reach at the top of the pole. She has to reach a point which is 1.3 meter below the top, right here. So this is the required distance. Now, she says, what should be the length of the ladder that she should use? I have to find the length of the ladder. You must have seen those wooden ladders which are placed here to reach at a particular height. Now, we have to find this. Next, when inclined at an angle of 60 degree to the horizontal, that ladder has to be placed so that it makes an angle of 60 degree with the ground, right? So let this P, Q, R and this point be S. Now, first of all, you have to find the length of the ladder. Next, also how far from the foot of the pole should she place the foot of the ladder. You have to find this distance also. What should be the distance between the foot of the ladder and this foot of the pole? So now initially we consider, let PQ be the height of pole, right? So PQ is equal to 5 meters. Let she has to reach point S. So what is the height of QS now? QS is 5 minus 1.3, that is 3.7 meters. She has to reach a point which is 1.3 meters below the top of the pole. Right? So this distance is 3.7 meters. Now in this triangle, one side is known to you. One angle is known to you. Right? And you have to find two different quantities. We will go for one in the first case. Now, in triangle SQR, this is a right triangle. So first we have to find this. Now let us see that this is 90 degree. The side opposite to 90 degree is hypotenuse. This is the concerned angle. So this has to be the base and this side has to be perpendicular. Now what is known to us? Perpendicular is known to us. Perpendicular is known to us and hypotenuse we have to find. What is the basic trigonometric ratio which is related to both? It is sine of that angle. So we can start with sine of 60 degree. Sine 60 degree is the relationship between perpendicular and hypotenuse. Perpendicular here is SQ and hypotenuse is SR. Value of sine 60 is root 3 by 2. SQ is the height which is 3.7 and SR we have to find, right? So you can cross multiply this SR into root 3 is equal to 3.7 multiplied by 2. So SR is equal to 3.7 multiplied by 2 divided by root 3. So SR becomes 7.4 divided by root 3. So here root 3 is in the denominator, so I have to rationalize the denominator in that case. This becomes 7.4 root 3 divided by 3. Right? Now since in this case we have given that root 3 has to be taken as 1.73. So we have to put the value and solve this question. So now we have to solve this. 1.73 into 7.4. 1.73 into 7.4. 4 3s are 12, 28 and 129. and 2, which is 6.92. 7 3s are 21, 2, 49 and 2, 51, 5, 7 and 5, 12, 2, 1, 2, 3. This is 12.802 divided by 3. Now we divide this by 3. 3 4s are 12.3 2s are 6, 23 6 are 18, 18 22 3 7s are. So this is approximately equal to 4.267 meters. Right? This is the value of SR. Now this was the first thing. Next we had to find how far from the foot of the pole should she place the foot of the ladder. That means we have to find this distance. Let this be X. Right? Now in triangle you have to start with this. In triangle SQR. Now this is known to us. This is known to us, and this we have to find. This is perpendicular and this is base. The trigonometric ratio which is related to perpendicular and base is tan. So tan of 60 degree is perpendicular SQ upon base QR. Tan 60 is root 3. SQ is 3.7. And this we have to find. X. So that means X is equal to 3.7 by root 3. And then we have to rationalize this. So this becomes 3.7 root 3 by 3. Now again we have to do this calculation. So 3.7 multiplied by, or you can divide this first like 3 1s are 3, 3 2s are 6, and then almost 1.23. So we have, this is 1.23 multiplied by 1.73. 1.73, and we can roughly take this as 1.2. 2 3s are 6, 2 7s are 14. 173, 6, 7. This is 20.76 or 20.76 meters approximately. Right? So the value of base in decimals becomes the second part. This distance of the ladder from the foot of the pole is 20.76. QR is 20.76. This is your second answer. And the first one was the the length of the ladder. Length of the ladder is 4.267. Right? The next question is, an observer 1.5 meter tall is 28.5 meter away from a chimney. Okay. See, here, this is a new thing. Height of the observer is given, and that is into consideration. We are not considering that the eye to be at the ground level. The eyes are at the top level. So this is the height of the observer, 1.5. An observer 1.5 meter tall is 28.5 meter away from a chimney. The angle of elevation of the top of the chimney from her eyes. Let this be the height of the chimney, and the person is looking at the top of the chimney. So this is chimney. Let this be PQ. This be RS, height of the observer. So in this case, this is the actual triangle which is working, because since the eyes are at this level, right? Eyes are at this level, so angle of elevation will be formed at this particular moment. The angle of elevation of the top of the chimney from her eyes is 45 degrees. So this is the figure. What is the height of the chimney? Height of chimney will be this whole length. You can see this whole length, not up to here only. This you can write as M. Height of chimney is PQ because it is referred from the ground. Now we label all these things. Let observer be SR. which is equal to 1.5 meter. Let chimney be PQ. PQ is taken as the whole height, PQ, which is equal to PM plus MQ. Now we can see that PM is unknown to us. We can take this as H. And MQ is given to us as 1.5. See, this is a rectangle. This part is a rectangle, right? In this if this is 1.5, this has to be 1.5. If this is 28.5, this is 28.5, right? So the height of chimney becomes H plus 1.5 meters. Now the distance of chimney. Distance of chimney from the observer is 28.5 meters. And angle of elevation. Angle of elevation is 45 degrees, which is equal to angle PSM. Right? Now we start and apply trigonometric ratio in this triangle. This rectangle is not of any use except we have to consider this 1.5 for both the things, the observer as well as the chimney. Now in right triangle PMSM, see, we have to find H and we know this is perpendicular. This is a concerned angle, so this has to be base. This is perpendicular. Again, the trigonometric ratio between perpendicular and base which works is tan theta. So we have tan 45 degrees is PM upon SM. Tan 45 is 1. PM we have considered as H. SM is 28.5. So we can say that H is equal to 28.5 meters. Now this H part is PM, right? Height of chimney we have considered as this. PQ is equal to PM plus 1.5 or H, which is 28.5 added to 1.5. The height of chimney is 30 meters. Height of chimney is 30 meters. Right? Next question is, from a point P on the ground, the angle of elevation of the top of a 10-meter tall building. From a point P on the ground, the angle of elevation of the top of a 10-meter tall building is 30 degrees. A flag is hoisted at the top of the building and the angle of elevation of the top of the flagstaff from P is 45 degrees. See, we have to first make this. Here two objects are one over the other. P is the point and let this be the building. From a point P on the ground, the angle of elevation of top of a 10-meter tall building. Elevation means we are raising our eyes from this level to see the top of the building, which is 10 meter high. Let this be QR. Now a flag is hoisted at the top of the building and the angle of elevation of the top of the flagstaff. See, flagstaff is a kind of pole to which the flag is attached. So this be the flagstaff. And the top of the flagstaff is this point. Then the angle of elevation of the top of the flagstaff P is 45. When we look at the top of the flagstaff, the angle of elevation here is 45 degrees, right? This is 45 degrees. Find the length of the flagstaff and the distance of the building from point P. Let this be point S. Now just try to analyze the question. From a point P on the ground, the angle of elevation of the top of a 10-meter tall building is 30 degrees. If we are looking at the top of the building from this point P, the angle of elevation is 30 degrees. And if we are looking at the top of the flagstaff, which is mounted on or over the building, this angle of elevation from point P is 45 degrees. Now we have to find this length. Let this be H. and the distance of the building from the point P. Let this be x. Let height of building, let height of building QR is equal to 10 meters. Height of flagstaff, which is SR, is equal to H meters. And the distance of point P from building, right? From building be x meters, right? Now angle RPQ is 30 degrees, which is angle of elevation of the top of the building, and angle SPQ is 45 degrees, which is the angle of elevation of the flagstaff. Now here we have to work these things in two triangles. So in first triangle, in right triangle RQP, what we can do is, in first triangle we can find x. You can see that this is known to us. This is the angle of elevation, so this has to be base. This is perpendicular. So in triangle, we cannot go for the height of flagstaff in this triangle. So from the smaller triangle RQP, we can use tan 30 degree as RQ upon PQ, perpendicular upon base. Tan 30 is 1 by root 3. QR is 10. And PQ we have taken as x. So now we can write x is 10 root 3 meters. Right? X is 10 root 3 meters. And this is the distance. We had to find the distance of the building from the point. One thing we have found. But we have here to use root 3 as 1.732. So value of x becomes 10 multiplied by 1.73. So x is 17.3 meters. Right? This is the first thing. Now we have to find the length of the flagstaff, h. For that, in triangle, you cannot use this smaller triangle. This has to be the full triangle. This. In triangle SQP. In right triangle SQP, what is the relationship? This is partially known to us and this is now fully known to us, right? So this is perpendicular, whole perpendicular, this is base. So again we have to use tan 45. Tan 45 is SQ upon PQ. Tan 45 is 1. 1 is equal to SQ. What is SQ now? This is H plus 10. This part is H. The lower part is 10. PQ is X. Right? So here, by cross multiplication, we can write X is equal to H plus 10. X is given to us, 7.3 we had found. Minus 10 is equal to H. So H becomes 7.3 meters. Right? So this height of flagstaff is 7.3 meters and distance of P from building is 17.3 meters. Right? And the last question is, the shadow of a tower standing on a level ground is found to be 40 meters longer when the sun's altitude is 30 degrees than when it is 60 degrees. The shadow of a tower. How is a shadow formed? See, if this is the tower and the light is coming from some luminous source, the shadow is formed like this. Let this be the tower. Shadow of a tower standing on the level ground is found to be 40 meters longer when sun's altitude is 30 degree than when it is 60 degree. I must tell you one thing. Even if you get confused about how to make when we have two angles, you always have to remember that the angle which is closer to the perpendicular object is the bigger angle. So in this case, the shadows are forming in two different cases. Two different cases. In one, the angle of elevation is 30 degree. The other, the angle of elevation is 60 degrees. So now it says, shadow of a tower standing on the level ground is found to be 40 meter longer. These are the shadows. In first case, this is the shadow when the angle of elevation is 60 degree. And this is the total length of shadow, which is angle of elevation is 30 degrees. Now this is 40 meters longer. That means this difference of shadows is 40 meters. In the previous case, when the angle of elevation is 60, the length of shadow is smaller by 40 meters. So that means this is the case. You can take this as R, this as S. QR is the shadow. When angle is 60 degree, this is smaller by 40 meters. In case when the angle of elevation is 30 degree, the shadow is longer by 40 meters. Now find the height of the tower. Let this be H and this shadow in the first case is X. So let height of tower PQ be H meters. Let shadow be X meters when sun's altitude is 60 degrees. Let shadow be X plus 40 meters when sun's altitude is 30 degrees. Right? So these are the things we have assumed in the introductory part. Now we go for these two triangles to find H and X both. Like in first case, in right triangle PQR, again this is the angle of elevation. This QR is base, this is perpendicular. So we have to use tan. Tan 60 is PQ upon QR. Value of tan 60 is root 3. PQ we have taken as H and this is X, right? So this we can leave it here as our equation 1 because we have two unknown things in the same equation. Now we go for the next triangle. In triangle PQS. PQS, that means the whole triangle, the bigger triangle, right? In this case, again this is 90 degree and angle of elevation is 30 degree. So this is tan 30 is PQ upon the whole denominator, whole base as QS. Now this is 1 by root 3. PQ is H. QS is X plus 40. Right? This is our second equation. Now again we have got two variables and two equations to solve them. Right? How can we do that? We can see from here we can write H is equal to root 3x. You can write here this as the first equation. And now let this be the second equation. Putting H from 1 in 2. Now see, in few cases we can equate few things which are not required in the question. But here we have to find both the things. It doesn't matter you go by X first or for H first. So here I have taken the value of H to be root 3x. So I can use it here 1 upon root 3. This can be written as root 3x. We solve it here. This is x plus 40. X plus 40 is equal to root 3 into root 3x, which is 3x. That means 40 is equal to 3x minus x. 40 is 2x. So implies that x is equal to 20 meters. Right? Now we have found this distance first. The length of the shadow when the angle of elevation is 60 degree. Now we have to find H. By this, h is equal to root 3x. So simply we can write h is equal to 20 root 3 meters. Since it is not given in the question that we have to find it in decimals, we can leave it here. So finally, height of tower becomes h, which is 20 root 3 meters. Right? So this was all about, these are different kind of examples which are given in the NCERT, and we have solved these 5 examples just to learn how to use trigonometric ratios to find different parameters in the given practical situations. I hope this is clear to you. So in the next video, we will start doing the exercises which is regarding all these questions. I hope you liked watching this video. Please like, subscribe and share it with your friends. Thank you.